Let's do it.
Jim Collison, we are live at Infotech 2014, and we're in the afternoon sessions. I have Ken Coulter with me from HDR, and he is here to talk a little bit about engineering, which right?
Yeah, architecture and engineering.
Architecture and engineering. And so tell us a little bit about yourself, maybe title, what you do, those kinds of things.
Okay, so I am the Interactive and Visual Design Manager here in Omaha's corporate offices. I work in software and systems development. It's within the information technology group. What I focus on primarily is developing interactive applications that can be utilized to help visualize a space, to be able to work with architects to deliver design solutions to the client and to help the designers themselves during that process, as well as making applications that enable interactive design decisions. So if you're in a virtual environment, either on a touch device, mouse-driven, or virtual reality like Oculus Rift, that you're able to envision that space and maybe switch out floor plans, change chairs, change colors, change materials for that design process, as well as being able to then go from that upfront perspective to taking that through the process of design and build, and then using all of the final built data, attributes from the CAD data like manufacturer, the quantification of materials, the size, its geospatial referenced location, and delivering that with a optimized 3D environment type of application that the client can then use in a BIM or a building information management methodology to interrogate that information and to also use it for things like operation and maintenance. So It's pretty powerful stuff.
Sure. Yeah, as you talk about that, I kind of think, I go back to the, or I go forward to the idea of a holodeck.
Yeah.
And right? I think that's kind of the ultimate end game, and some of this is being able to virtually, in a very real sense, interact with an environment, change it. You talk about being able to change the chairs, change the design. We had talked just before we went on about maybe even being able to see the wiring in a wall before it happens.
Yeah.
Where are we at today, realistically? Where are we at today with that? What kind of things can I do?
Sure. So we already are creating deliverables. So with architecture on kind of the design side, a lot of times what they do is they'll create one-to-one foam core mock-ups of a room or an environment. So looking at, instead of doing that, or to supplement that experience, being able to create a virtual one for the clients to envision the space, use the Oculus Rift, and then that same application with a few tweaks to the programming and the functionality can be turned into the deliverable on the design bid. So when we're trying to get a job and we're sending all of our supporting materials on the project, that's one of the realities that we're currently developing for. The other one, I can't disclose the project, but we are actually creating as per contract, basically a virtual 3D model that's connected to a database for the as-built version of a giant structure that we're currently developing. So we are doing it for real. It's not just pie in the sky.
Yeah. Does it? So that is a little bit like that, like a holodeck in some way.
With the Oculus.
Yeah, right. So instead of being in the room, you have a headset on.
Right.
Boy, the Oculus Rift really came out of nowhere. It seems like all of a sudden now it's all the talk. Have you been looking at that longer than it's been in the news?
No, I think I kind of jumped on the bandwagon when a lot of other people did, but I looked at how to implement it to really make a difference in the field that I'm working in. And a lot of that technology has been around for a long time, and it kind of resurfaced, all due to the folks at Oculus VR being able to find really sophisticated and capable ways to do it in an inexpensive fashion. So Google Glass is like $1,500 or $1,600. Oculus Rift, when the first SDK came out, was $300. The new one that has the head tracking is about $350. It went from LED to OLED display, so it's a little bit better. And then the refresh rate's also higher, so that hopefully helps people keep from feeling so dizzy.
Yeah, that's right. That's a big problem. I have not tried it yet.
You're gonna have to do that.
Well, will that fit over my glasses, or do I have to take?
Yeah, it'll fit over your glasses.
Okay.
Most people that even do wear glasses tend to like it better without them.
Oh,
yeah.
I'll have to give it a try. No, I've watched it from afar, and maybe a little skeptical of it, but at this point, I think it's one of those things that it's arrived.
Yeah.
I think at this point, you had mentioned using gaming engines in some of what you do. Why? What is it about those that is different?
Sure.
Yeah.
So one of the things that I used to do a lot of before I came to HDR was a lot of animation, a lot of interactive application development using Flash when Flash was still kind of alive. before Steve Jobs kind of kicked it to the curb.
Yeah, he crushed it, kind of. Yeah.
So a lot of that process is extremely render time consuming. So when you create your environment, your animation, you have to hit the render button. That process can take hours to days, even if you're using a dedicated render farm. And you can get some really nice high quality work out of it using Mental Ray and V-Ray, which are rendering, post-production rendering processes as well. So, the work that I was doing as a litigation consultant, as we were talking about previously, a lot of changes when you're at trial, you can't take 3 days to do. So during a break or between witnesses, I have to make changes to animations or to a file of some kind, and having to tell an attorney that's not going to happen,
but it's
and
going
what
to
we've
take
been working on for a month is totally worthless now. It doesn't go very well. So I started to use RealTime Engines because I had done a lot of educational video game development before that. And so I thought, well, there's got to be a place for this. And so it's a lot easier to go through the same methodology of building the environment, establishing texture maps, and then if a change needs to happen to a model or to a timeline sequence, it's a real quick change and adjustment to a keyframe or to bring in a new model, and everything else just works and you're good.
So the advantage is in one model, it's rendering everything all at the same time, right? It's rendering everything. With the video game, it's rendering it in real time, and it's just giving you the things that you need to see in real time, right?
Right. With the RealTime engine, it's all based on draw calls. So as it's going by frame, it's only pulling the necessary models and texture maps. But with rendering, it's also a lot about that you have to render layers typically for a high quality animation or rendering. You might render like an ambient occlusion pass, a color pass, a spectrum and shadow pass, and that all has to be composited in post-production and sandwiched together. And then that has to be edited and exported. So there's a lot of work that has to be done there. With CAD data, though, that's the big bottleneck with architecture and engineering. So when all of that CAD data is built in any of the CAD software that I won't throw anybody under the bus on, but it's inherent to all of the CAD packages, they're not really focused on how much topology are you using to define the surface. It's more, is there the appropriate structural integrity? Do things hold up the way that they should? And they're focused, of course, on the things we all are glad they're focused on, so things don't collapse. But at the end of the day, when they export that, or we export it from their CAD software to use it in the application, it's typically anywhere from 50 to 1,000 times heavier than it needs to be. So all of that geometry has to be rebuilt. So if anybody listening is doing a PhD dissertation on a magic button to retopologize geometry, I'm sure there's millions in it.
Just fixing the CAD, the CAD problems alone.
We didn't have to do that.
Yeah, it's okay. And so quality-wise, though, are you getting the same in a real-time engine video game? Getting the same video quality that you're getting in this kind of the older, heavier, way of doing it?
The rendered process?
Yeah, the rendered process.
Yeah, I mean, obviously with some of those real Hollywood post-production effects that you can get with V-Ray and other renderings, you can get a higher visual fidelity, but all of that is really coming up to pretty close to par with RealTime engines. Unity, which is the RealTime engine that I use, or that we use at HDR, is this year with version 5 that's coming out. It'll be using WebGL, so it'll be embedded into web without having to have a plugin, which will be great. And
HTML5 compliant then, right?
It will also be utilizing physics-based shaders. So if you apply what type of material it is, it responds the way that it should in real life, based on the illumination of the environment, and then global illumination, which is how we are all really illuminated based on particles of light or photons. So it has photonic emission capabilities.
Yeah, incredible.
So that gap is narrowing.
Yeah, pretty fast.
Pretty fast. The hardware and the software are really catching up pretty quickly.
Yeah, who are the leaders in that area that you're following? You mentioned the gaming engine, but who are the leaders you're following in that industry right now?
Unity itself. I mean, they put out some pretty incredible stuff. They're at the forefront. There's a lot of people that are doing, a lot of tinkerings and musings about, but like Facebook, for example, who just bought the Oculus VR. I think I just recently read that 70% of their games on Facebook are all made with Unity. So it's coming up.
Okay, let me ask you, on the physical side, 3D printing has come a long way, and it continues to become more. Are you looking? You guys do much 3D printing? Work in that space?
Yeah, the one project that I aforementioned that I can't disclose, they did a printing of that, and it's pretty awesome. But in my litigation consulting past, we did some for computer chip semiconductors, 3D prints of those, and they came out pretty well. But there's a lot of banding still, and it's very rigid, and we tried to paint it and sand it, and it just doesn't really respond the way that you want to. And then the one that they have here, that one has a lot of ribboning where things kind of fall apart. So it's just not where I want it to be yet. What I'm more interested in is augmented reality and trying to integrate some of that capability into what we're doing.
Explain that a little bit. What does that mean?
Well, like you were saying before with the X-ray stuff, just how awesome would it be to hold up your Surface or to hold up another device and to be able to see everything from the model that's geospatially synchronized with where you are in space to the building. So if this conference center had a 3D model of it, and we were geospatially synchronized with the 3D model that we're looking at, being able to use that kind of as a window to look around through that environment would be pretty sweet.
Be able to see through the walls.
See through the walls, turn things on and off, or to receive information. What if I say, there's a specific attribute that I want to see for every single object, and here I can turn that on, and as the camera intersects it, it'll give me that information that I need. It could also direct me to where I need to go.
Yeah.
This was a lot of.
Now that would be based on the plans, the original plans that were put in place, right? And so in saying that assumption, you're assuming that when they actually did it, they did it that way?
Yeah, you're correct. And there's subtle changes. Once something goes through the RFC process, the request for construction, it's pretty solid. It doesn't change unless there's a condition in the environment when they're doing construction that something needs to be adjusted. But that's all documented in the reports.
So it would be pretty safe, right? You'd be drilling into the wall. Hey, there's supposed to be a
and if they make any changes later, that model would need to be updated. That's kind of the whole idea of client for life.
Yeah, well, we saw, when we talked about 3D, I did a interview with some high school students out at Millard North here in town, and they've got a big, expensive 3D printer, and they've done some pretty cool things, for high school students. You're right, still a little big, still a little bulky. The heads have to get smaller. The materials need to change. We're probably going to need to have multiple heads. Remember the old IBM, probably not you, the old IBM Selectric typewriter, that head moved around and
huge.
Gigantic. We're probably going to need to have some swappable heads where it can change, it can change materials quickly, because the materials will only get better at this point. They'll figure they're going to get some feedback and figure some things out.
It'll keep going. It's the right idea in the right direction. It's just not to the quality yet that I think a lot of people want.
And then some bioprinting, right? Can you manufacture proteins?
Yes, and actually,
and build those.
Some of my previous experiences, I'm a medical illustrator also by trade. So got my master's in medical illustration, and was a professor assistant professor for a while, I should clarify. And that was a lot of fun. So the bioprinting, creating meshes, artificial limbs, artificial bone, artificial prostheses that match up perfectly. Like if you need a new hip and you need to have a scan done based off of an X-ray or a CT scan, they can do a model that fits perfectly with your acetabulum. So it'd be pretty awesome. And
then just print you a new bone.
Well, or
Here's
just it prints the implant.
Here's the femur. There you go. I think we're in the early stages of that. It'll be interesting to see where that goes.
It's getting sci-fi awfully quick.
Well, like the PC led to the phone revolution, I think some of this early 3D printing will lead to some, the ability, even to be able to print food, so to speak.
That's an interesting concept, Cloudy with a chance of meatballs.
Yeah, exactly.
Right.
Yeah, just print that out. Thanks for taking a few minutes with us, and some very interesting. I find one of my favorite things about doing this is I get to really get to have some interesting conversations on things that I'll probably only experience, never get to work with. So
you never know. But thank you very much for having me.
No, thank you.
Pleasure.
Appreciate it. Thank you.